You know that simple house key on your keychain? Take a good look at it. It seems pretty basic, right? Well, what if I told you there's a way to give that key a high-tech, invisible suit of armor? We're about to dive into the hidden science that can turn this everyday object into something, well, something extraordinary.
I mean, we've all seen it happen. You get a new key, it's all shiny and sharp, but over time it just loses its luster. The edges get worn down, and the metal plating starts to fade right where your thumb rests. It's a small thing, sure, but it's a perfect example of everyday wear and tear. But what if it didn't have to be that way? So today, we're going to follow the journey of one totally ordinary, nickel-plated brass key as it gets an incredible upgrade. Think of this as the origin story for a super key, where we turn a really technical process into a fascinating tale of engineering and material science.
Okay, so before we can really appreciate the solution, we've got to understand the problem. What exactly is a standard house key up against every single day? Let's break it down. A key's life is actually pretty rough. The teeth are constantly grinding against the lock's pins. That's abrasive wear. The nickel plating fades just from the oils and friction from your hands. It's always getting scratched up by all the other stuff on your keychain. And yep, even humidity and sweat cause corrosion over time. All of this just adds up to high friction, which makes the key feel sticky and harder to use. It's a tiny daily frustration, but it really shows how even strong materials break down without the right protection. All right, so what's the fix? Well, this is where the hero of our story comes in, a high-tech armor called Chromium Nitride, or CRN for short. You can seriously think of it as a custom-fitted supersuit for our humble little key. So what is this stuff? Chromium nitride is a type of ceramic coating that is just incredibly hard and ridiculously resistant. It's applied in an ultra-thin layer that creates this amazing protective barrier against pretty much all the problems we just talked about. It is absolutely the key's secret weapon against that daily grind. Now, check out this number. HV stands for Vickers hardness, which is just a fancy way of measuring how well a material resists getting scratched or dented. A score between 1800 and 2000, that is wildly high. To put it in perspective, the original nickel plating on the key doesn't even come close. This incredible hardness is exactly what gives it that superior protection against, well, everything. And this table right here really lays out the whole transformation. The wear resistance goes from low to superior. Friction, you know how smoothly it glides in the lock, plummets to a super low coefficient of about 0.3. That means it just works better. It becomes highly resistant to rust and corrosion, and it even gets this really cool, sleek, metallic gray look. It's a complete upgrade from top to bottom. So the big question is, how do you actually get this magical coating onto the key? This is where things get really, really cool. Let's go inside the transformation chamber. All this magic happens through a process called Physical Vapor Deposition, or PVD. The easiest way to think about it is like spray painting, but you're using individual atoms inside a vacuum. It's a three-step dance. First, the key gets an intense ultrasonic cleaning. Then it gets zapped with argon plasma, which is kind of like sandblasting it on a microscopic level so the new coating can stick perfectly. And finally, inside that vacuum chamber, the chromium nitride is deposited, literally atom by atom, right onto the key's surface. And here's the most crucial part, the thickness of this super armor. We're talking 1 to 5 micrometers. That is thinner than a single human hair. And that's absolutely critical, because it's just strong enough to protect the key, but it's also thin enough that it won't change the key's shape and cause it to jam in the lock. It's a perfect, delicate balance. Okay, so the key is transformed. It's a super key now. But like any advanced engineering process, this isn't without its challenges. There's some real pitfalls to watch out for. So let's talk about the risks versus the rewards. The rewards are pretty clear, right? A much longer lifespan, a smoother feel every single time you use it, and that premium look. But it's not foolproof. The risks are very real. If that coating is just a tiny bit too thick, the key could jam. If the cleaning wasn't absolutely perfect, the coating might not stick properly and could flake off. And getting the coating perfectly even on the sharp, tiny edges of the key's teeth, that's really tricky. This is a high-precision job. So why does any of this matter? I mean, it's just a key, right? Well, this is where we zoom out from this one little object to a much bigger, and I think much more important idea about the things we use every day and how we can make them so much better.
This quote from the person who did this project really gets to the heart of it. It's a simple lesson, but it's so powerful. This kind of technology is perfect for any situation where you need something to be incredibly durable, but also incredibly precise. So this isn't just about keys. It's about making countless other objects better, stronger, and longer lasting. And that right there is the ultimate takeaway. When we apply advanced science to something as simple as a house key, we can dramatically extend its life. And what does that mean? It means less metal waste from constantly replacing worn-out stuff. And ultimately, it means higher quality, more reliable products for all of us. It's a small change that could have a huge impact. So, as we wrap this up, I want to leave you with a question to chew on. Just look around you right now. What other simple, everyday object do you think could be completely transformed with a little bit of material science magic? The possibilities, when you think about it, are literally everywhere.